Okay, so let's have another look at a Calculus AB question, and this is without a calculator. So here we're provided some information that we're told about a height of a tree given by a twice differentiable function. H is measured in meters, t is measured in years, values for h of t. So I can think of the time as my x variable and the height as my y variable. Using the data, estimate h prime as 6 using correct units, interpret the meaning. Okay? I want you to get into the habit of thinking about the meaning first. All right? So h prime of 6 represents the rate of change of the height of the tree in meters per year when t equals 6 years, right? That we can get in the habit of writing our explanations first. H of prime is clearly a rate of change of h, but we want to talk about what h represents. So h prime of 6 represents the rate of change of the height of the tree in meters per year when t is 6 years old. Right? It's the slope of the growth, or it's the slope of the height function. Now, how do we estimate that? Well, h prime of 6 is going to be approximately equal to, well, let's look at our data table. It's going to be approximately equal to h at 7 minus h of 5, because 6 falls between there, all over 7 minus 5. Right? If I do that, that's going to be 11 minus 6 all over 2. And we already do have the units, but it doesn't hurt for us to be able to talk about, hey, that's going to be meters per year. Okay. The next part asks, explain why there must be a time, right, such that h prime of t equals 2. So let's provide our answer here, right? Because h of t is twice differentiable, what they told us, right? That means that h of t is continuous on our interval. And what's our interval here? Our interval is from 2 to 10. Right? By the mean value theorem, right, h prime of t will equal, now we need to set up a little piece, h of 10, right, the average slope, so the value at 10 minus the value at 2, all over 10 minus 2, which in this case is equal to 2. So we have a twice differentiable function, which tells us we're continuous on our interval, and by the mean value theorem, that derivative, that instantaneous rate of change, has to equal the average rate of change. All right, that instantaneous rate of change has to equal the average rate of change. So we have that piece that has to be true. But here's where we have to be careful, all right? Because if we look at this, we're like, well, wait a second, all right? H of 10 minus h of 2 over 10 minus 2, that's not 2. We need somewhere where our slope is going to be 2. And so what we find out is, no, it's not going to be h of 10 minus h of 2. Rather, it's going to be h of 5 minus h of 3 all over, right, 5 minus 3, because that's equal to, right, well, what is that actually equal to? Well, h of 5 is 6 minus h of 3 is 2 all over 2, and 4 divided by 2 is 2. So be careful about just using the endpoints that you're given, because that may be one of the little things they try to sneak in there. Okay, so if you just memorize, you can get by with some things, but you're not necessarily going to get full credit. So for this one, you had to refer to the interval specifically that'll give you a slope of 2. Okay, then part C, use a trapezoidal sum with 4 subintervals indicated to approximate the average height of the tree. And our average height is going to be given by that 1 over b minus a formula, integral from a to b of f of x dx. And if I do that here, that's going to be 1 over 10 minus 2, all multiplied by, now we're going to do our trapezoids because they're total trapezoids. So 1/2 the first base plus the second base, right, times the width of our interval, which in this case is 1, plus 1/2 the first base plus the second base times the width of our interval, 5 minus 3, plus 1/2 first base plus second base times the width of the interval, in this case 2, and then lastly plus 1/2 the first base plus the second base times the length of our interval, in this case 3. So there we have our approximation for the average value of the height function. We're approximating the average height. And lastly, the height of the tree is also modeled by a function where x is the diameter at the base of the tree. Tree is 50 meters tall, right? Then what are we going to have, right? So let's come through and consider our information here, okay? So if we come and do our work, we have that we want to find the rate of change of the height. So if we take the derivative with respect to time, because it says with respect to time, of g of x, not g prime, right? If we take the derivative with respect to time of g of x, we're going to have a quotient rule. And that quotient rule is going to be that bottom times the derivative of the top, which will be 100, but then x prime, because it's with respect to time, minus the top times the derivative of the bottom, so that's x prime, all over the bottom squared. Now, we want to figure out when the tree is 50 meters tall. So we want this to figure out when g of x, which is 100 over 1 plus x, is equal to 50, or 100x over 1 plus x. So clearly by inspection, x is equal to 1, because 100 times 1 divided by 2 is 50. So we want this evaluated at x equals 1, and we know that the diameter of the base of the tree has this increase, and x is the diameter, right? And so we have this at x equals 1, x prime equals 0.03. So our solution is going to be 1 plus 1 times 100 times 0.03 minus 100 times 1 times 0.03 all over 1 plus 1 squared. And if this is an open response question without a calculator, that's a satisfactory answer. But we could expand this if I wanted, right? We could say, hey, that's going to be 2 times 100 times 0.03 is 3 minus, right, 100 times 1 plus 0.03. So that's 2 times 3 minus 3 all over 1 plus 1 squared. That's 4, which would give me 3/4. And of course, it tells me meters per year, right? But I could also set that up with my units, okay? Marks for this particular one, right? Marks for this particular one. If we get our setup, that's a mark. If we get the right answer with our units and the interpretation, right? And if we do that, right, we have our estimate for getting that first mark. We had to actually write it with the actual values. And then our representation with units has to have the units, and it has to talk about a rate of change of the height of the tree. Then we have 2 marks there. Okay. For part B, I have to look at specifically this average rate of change, and I have to talk about being twice differentiable, therefore being continuous with the mean value theorem. All right. So I've got 2 marks there. Do I have the right interval I consider, and do I talk about being continuous with the mean value theorem? Okay. For part C, I have to look at 1 over 10 minus 2 for the average value piece, and I have to do my trapezoid approximation. If I make that attempt at the trapezoidal approximation, I'll get a mark. If I remember to multiply all of that approximation by 1 over b minus a, I get the second mark. And then lastly, for our last problem here, if I make this attempt to find the derivative of g of x, that's a mark. If I correctly find the derivative, that's a mark. If I get to the correct answer with the substitution where x is 1, that's a mark. So a total of 9 marks on these free response questions. How you get the setup is going to be the majority of your work. But you want to do the setup and then put the right numbers into the right places. Okay. Thank you very much for your time. Make sure that you keep on asking questions for clarification as you need.